Hello everyone, very good evening to all of you. Welcome to this amazing platform of Knowledge Planet powered by Physics Wallah. So as you all know, we have studied the chapter 2 vectors in very much detail in our class, covering all the minute topics and practicing a lot of questions. So today is the time for ultimate recap of our chapter 2 vectors. In today's class, we will revising all the topics, important formulae, so that you get a quick recap, a snapshot of the chapter in small time. So in today's class, we'll be covering what are vectors, how vectors are represented. Then we'll be going to vector addition. We know that there are laws of vector addition. Vectors do not follow scalar algebra, they follow vector algebra. Then we'll be going how we represent vectors in Cartesian coordinate system, and then we'll be doing all the properties, how to add, how to find magnitude, how to find unit vector in Cartesian coordinate, direction, cosines, everything. And then we will go to vector multiplication. So as there are laws for vector addition, vector multiplication is also different. There is scalar multiplication and a vector multiplication. Okay, so we will be covering all these topics in today's recap. So let's start our session with what are vectors. So as we all know that till now we have studied scalars. Scalars are just numbers which have only a magnitude. They do not tell us anything about the direction. If I say distance of 4 meters, it is me telling me that I have covered a path length of 4 meters, but it's not telling me in which direction I have covered this path length, whether I went like this or went like this. Okay, so what are vectors? Vectors, those physical quantities which have both magnitude and direction. Those physical quantities which have both magnitude and direction and obey the laws of vector addition. This is very important because we know a quantity called current. Current has a direction but doesn't obey the laws of vector addition. So current is a scalar quantity. It is not a vector quantity. What are vectors? The physical quantities which have both magnitude as well as direction and obey the laws of vector addition are called vectors. In physics, we encounter a lot of vectors: displacement, acceleration, velocity, force, linear momentum, angular momentum, torque. All these are vector quantities. Okay, so what we have vectors? Vectors have both magnitude as well as direction. Now how we represent vectors? How we represent vectors? Vectors are represented by a arrow. Okay, vectors are represented by a line having an arrowhead over it. So this, where the arrow is placed, this is called my head of the vector, and where the vector is starting is called tail of the vector. This is called tail and this is head. Now in which direction this arrow will point? This arrow will point in the direction in which I want to show my vector. Okay, if there is a force of 2 Newton in this, then I'll point the arrow in this direction. Okay, this arrowhead will point in the direction of the vector. Arrowhead will point in the direction of the vector, and this length of my vector, okay, this length of my vector, it tells me magnitude of the vector. Okay, it tells me magnitude of the vector. How we write a vector? If this is my a vector, okay, if this is my a vector, then how will I represent a? A will be represented as write a and draw an arrow above it. Okay, write a and draw an arrow above it. This means it is a vector. Okay, this is a vector. How we write magnitude? Magnitude is written as mod of a vector. Okay, this mod of a vector will give me its magnitude, or sometimes it is also written as simply a vector. Okay, sometimes it is also written as simply a vector. Now magnitude is equal to length of the vector. Magnitude is equal to length of the vector. My length of the vector tells me the magnitude of the vector, and the direction in which the arrowhead is pointing will tell me the direction of the vector. Is it clear? So, see, types of vectors. How many types of vectors are there? There are many types of vectors. First is collinear vectors. Those vectors which act along the same line or parallel line, which act along same line or along parallel lines are called collinear vectors. So, if the vectors are acting in the same direction, okay, if my vectors are acting in the same direction, or if they are along the same line, then this is called parallel vectors. This is called parallel vectors. Parallel vectors, okay. And if they are acting along two parallel lines or along the same line but in opposite direction, these are called anti-parallel vectors. They are called anti-parallel vectors. So, collinear vectors which act along the same line or along two parallel lines. Now, they are acting along same or parallel lines. They can act along in the same direction or they can act along in the opposite direction along the same line. So, if they are acting in the same direction, these are called parallel vectors, and if they are acting in the opposite direction, they are called anti-parallel vectors, okay. They are called anti-parallel vectors. So, collinear vectors are further into two types. Next type is coplanar vectors. Collinear, same line. Coplanar, same plane. Vectors which act in the same plane are called collinear vectors. If I draw two vectors, one is A vector and the other is B vector. Now, these vectors are present in the same plane, in the plane of my board, okay. They are present in the same plane of my board, then they are called coplanar vectors, okay, having same plane. Next is co-initial vectors. Co-initial, same initial point. If my two vectors are originating from the same initial point, then they are called co-initial vectors, okay. How I will draw co-initial vectors? Like this. They are having the same point O as the origin, okay. O as their origin, initial point or starting point, then they are called co-initial vectors. Next is coterminal vectors. So, coterminous vectors or coterminal vectors having the same terminal point, when my vectors terminate at the same point, like this, okay. When my two vectors are terminating at the same point, then they are called coterminal vectors. Next come polar vectors. Those vectors which have a starting point, okay. Those vectors which have a starting point and a point of application, they are called polar vectors. Have a starting point or a point of application are called polar vectors. So, this is a polar vector. This is having this as the initial point and this as the final point. They are acting, either they are acting at this point or they are originating from this point. Such vectors are called polar vectors, okay. Such vectors are called polar vectors. They act at some point or they originate from a point, okay. This is the originating point of my polar vector. So, all are vectors like force. It is a polar vector, okay. See next, axial vectors. Now, polar vectors have a starting point or a point of application. Axial vectors, those vectors which act along the axis of rotation. We use these vectors to represent rotational effects. When we will study rotational motion, then we will come into quantities whose directions are along the axis of rotation, such as angular velocity or angular momentum. All these vectors act along the axis of my rotation. So if my particle is rotating like this in this plane and this is its axis of rotation, so omega will act along this direction, and similarly sorry, and similarly angular momentum will also act along this direction. They act along the axis of rotation. And how we show their direction? We show their direction according to the right hand thumb rule. Okay, we show their direction according to the right hand thumb rule. Such vectors are called axial vectors. Okay, such vectors are called axial vectors. Example of axial vector is angular momentum. Angular momentum. Okay, this is an example of axial vector. Next is zero vector. Zero vector. Any vector whose magnitude is 0. Okay, any vector having 0 magnitude. Now because this vector is having 0 magnitude, so its length will be 0. When its length will be 0, it can have any arbitrary direction. Okay, it can have any arbitrary direction. So any vector whose length is 0 and any arbitrary direction, it is called a zero vector. This is also called a null vector. Okay, zero vector is also known as null vector. And how we represent it? We represent it by 0 with an arrow above its head. Okay, 0 with an arrow over its head. This is how we represent zero vector. Next is unit vector. A vector having unit magnitude. Unit magnitude means magnitude is 1. So a vector having magnitude 1. Any vector whose magnitude is 1 is called a unit vector. Any vector whose magnitude is 1 is called a unit vector. How we represent it? We represent it by a cap, not an arrow above its head. Unit vectors are represented with a cap over its head, and it is read as a cap. We will read it as a cap. Okay, so this is my unit vector a cap. They are used to show directions. Okay, used to show directions because we have fixed the magnitude. We have fixed the magnitude as 1. The magnitude of the vector should be 1. So they are used to show directions. Okay, these vectors are used to show directions a cap. Okay, how can we calculate a cap? Now a cap will be equal to, see, a vector is having both magnitude and direction. Now if we divide the vector by its magnitude, then the magnitude, we have divided it by its magnitude, so its magnitude will become 1 and we'll be left with only direction. So how we show a cap? A cap will be equal to a vector divided by its magnitude. A vector divided by its magnitude. Next comes equal vectors. So if I say 2 is equal to 2, there is only one thing, magnitude. What is we are having? If they have 2 pencils over here and 2 pencils over here, I'll say they are equal number of pencils. They are equal. Now vectors have both magnitude as well as direction. So for vectors to be equal, both the magnitude as well as the direction should be equal. Okay, both magnitude as well as direction should be equal. That is, two vectors are said to be equal if they have the same magnitude and direction. Two vectors are said to be equal if they are equal in magnitude as well as direction. Two vectors are said to be equal if they are equal in magnitude as well as direction. Vectors have two components, magnitudes and direction. Okay, so both should be equal for two vectors to be equal. Okay, same magnitude, same direction. Let's move forward. See, laws of vector addition. Before studying laws of vector addition, let's study one more thing, that if this is my vector and I displace it parallelly. Okay, if this is my vector, I displace it parallelly. Displace it parallel. I have displaced it parallel to itself. Now tell me one thing. If I displace this vector over here, then I will draw its vector like this. Now, is my vector equal? Is my vector equal? Yes, because if I have a vector like this, I have a vector like this, and I draw a vector like this, and I draw a vector like this, then I have, what I have done is, I have just displaced a parallel to itself. I have just displaced a parallel to itself. When we are displacing, neither the magnitude is changing nor direction is changing. So vector will remain same. Okay, vector will remain same. Okay, vectors do not change under parallel displacement. Vectors do not change under parallel displacement because magnitude is same as well as direction is same. Okay, because magnitude is same as well as direction is same. Same magnitude, same direction, vector will remain constant. Scalar multiplication of a vector. Scalar multiplication of a vector. Now see, if I have a vector like this, okay, this is my a vector, this is my a vector. Now I have multiplied a with 2, so I want to define 2a vector. 2a vector means its magnitude will become double, but direction will remain same. Magnitude will become double but direction will remain same. So if I have a vector and I want to find 2a vector, so 2a vector will be in the same direction but different magnitude. Magnitude has become 2 times. So if I have a vector lambda a, if I have a vector a and I want to find lambda a, that is, I have multiplied a vector with some scalar number. I have multiplied my a vector with some scalar number, then length will become lambda times. Okay, length will become lambda times, or we can say that this is my new vector, let's say a prime. This is my new vector a prime, where a prime is equal to lambda a. So magnitude of a prime vector will be equal to lambda times the magnitude of a. This will be equal to lambda times the magnitude of a. So vector will change. Now the magnitude has changed, so vector will change. Whenever one of the things changes, either magnitude or direction, okay, whenever one thing of my vector changes, either its magnitude changes or its direction changes, vector will change. Now the magnitude has changed, so vector will change. Now if I have a vector and I rotate it by some angle theta, this was my a vector and I rotate it by some angle theta like this. Now this will be my a prime vector. Direction of a vector is this. Direction of a prime vector is this. Direction of a vector is this. Direction of a prime vector is this. Now rotated by angle, rotate a by angle theta. So what we have is direction will change. Okay, direction will change. So my vector will, what conditions do we have? A vector changes if it's either magnitude or direction changes, and a vector remains same if both of them are same. So only in the condition of parallel displacement my vector is not changing. If I multiply my vector with some scalar number, my vector will change, and if I rotate my vector, then also my vector will change. Okay, now how to find angle between two vectors? How to find angle between two vectors? Angle between two vectors. How will I find my angle between two vectors? The angle between the tails, if this is my A and this is my B vector, the angle between the tails of the vectors, okay, either we have to take the angle between the heads or we have to take the angle between the tails. Angle between two vectors, it is the angle between their tails. It is the angle between their tails. Okay, it is the angle between their tails. So for here, theta will be the angle between A vector and B vector. Theta will be our angle between A vector and B vector. Suppose we have A vector like this and B vector like this, and this angle is given as theta. This angle is given as theta. Now the angle we are given is between the head of A and tail of A. So this is not the angle between A and B. What we will do is we will parallelly displace this A like this. So this will become, displace A parallel to itself. This angle is the angle between A and B. So in this case, angle between A vector and B vector will be pi minus theta. Angle between A vector and B vector will be pi minus theta, not theta. Angle between two vectors is always the angle between their tails or the angle between their heads. Now let's come to vector addition. We know that there are three laws of vector addition. Okay, there are three laws of vector addition. So first is triangle law. Triangle law of vector addition. Next we have is parallelogram law. Parallelogram law of vector addition. And lastly we have is polygon law of vector addition. So we have three laws of vector addition. First one is triangle law of vector addition, next is parallelogram, and next is polygon law. Vectors do not add by scalar algebra, like 2 plus 3 is 5. So a vector of 2 magnitude and a vector of 3 magnitude is never equal, or it can be, it may or may not be. Okay, it may or may not be equal to 2 plus 3, that is 5. It is not always 5. Okay, it is not always 5. So vector addition, the addition of two vectors will depend upon the angle between them. So first let's see what triangle law says. That triangle law says that if I have two vectors A and B, okay, if I have two vectors A and B which can be represented both in magnitude as well as in direction by the two sides of a triangle taken in the same order. Okay, if I have two vectors A and B and I represent them by the two sides of a triangle taken in the same order, then this third side of the triangle, taken in the opposite order will give me the resultant of A and B. Okay, then this third side of the triangle taken in the opposite order will give me the resultant of A and B. This is what triangle law says that. Next comes parallelogram law. Parallelogram law says that if I have two vectors A and B which are to be added, okay, if I have two vectors A and B which are to be added, and I can represent them by two sides of a parallelogram, two adjacent sides. Which sides? Which sides? Adjacent sides. If I can represent the two vectors by two adjacent sides of a parallelogram having the same initial point, okay, then the resultant of these two vectors will be represented by the diagonal of the parallelogram originating from the same point, okay. Then the resultant will be represented by the diagonal of my parallelogram from the same initial point, okay. What parallelogram law says that if I have two vectors A and B which are to be added, and I can represent them both in magnitude as well as in direction by the two adjacent sides of a parallelogram having the same initial point, then the diagonal of this parallelogram will represent the resultant vector both in magnitude as well as direction originating from the same initial point, okay. If these are two vectors to be added, then they will form this parallelogram. The resultant will be the diagonal of this parallelogram. Clear? This is what parallelogram law says that. Next comes polygon law. So polygon law says that if I have a number of vectors to be added, and I can represent them both in magnitude as well as direction by the sides of an open polygon. I can represent them both in magnitude as well as direction by the sides of an open polygon taken in the same order, then the closing side of my polygon, will give me the resultant of my all the vectors but taken in opposite order. If I have a number of vectors which are to be added, and I can represent those vectors by the sides of an open polygon taken in the same order, then the resultant of my all these vectors will be represented by the closing side of my polygon taken in the same order. So here R vector will be equal to, A vector plus B vector plus C vector plus D vector plus E vector, okay, plus E vector. So this closing side will give me the resultant of all the vectors. Now let's do the analytical treatment of vector addition. What vector addition is? What will be the magnitude of this resultant and its direction, okay. So if this is my A vector and this is my B vector, if this is my A vector and this is my B vector, and I want to add these vectors, now I have to draw is a parallelogram which is formed by the two vectors. So this is the parallelogram formed by the two vectors. Then the diagonal of this parallelogram, will give me the resultant vector. This diagonal will give me the resultant vector. This is my A vector and this is my B vector. Now we want to find what will be my magnitude of this vector R and what its direction will be, okay. So A and B are inclined to each other at an angle theta, okay. A and B are inclined to each other at an angle theta, and this resultant is making an angle of beta with my A vector. Okay, this resultant is making an angle of beta with my A vector. Now what will be my magnitude of R? So magnitude of R will be equal to under the root of A square plus B square plus 2AB cos of theta, that is angle between the two vectors. What is theta? Theta is the angle between two vectors. Theta is the angle between two vectors, and in which direction this R will point? Tan beta. For that we have to calculate tan beta. So tan beta is equal to B sin theta divided by A plus B cos theta. Okay, tan beta will be equal to B sin theta divided by A plus B cos theta. So these two are very important formulae for the chapter. Okay, if we want to find the resultant of two vectors, so R will be equal to under root of A square plus B square plus 2AB cos theta, where theta is the angle between A and B, and the angle with angle resultant vector will make with A, that is beta. Tan beta will be equal to B sin theta divided by A plus B cos theta. Now if magnitude of A vector is equal to B vector, if magnitude of A vector is equal to B vector, then this resultant is equal to 2A cos of theta by 2. Okay, then this resultant will reduce, this complex formula will reduce to this simpler formula, that if we have A vector and B vector are equal vectors, then equal in magnitude, not direction. Okay, equal in magnitude, then the resultant will be equal to 2A cos of theta by 2. This is what a magnitude of resultant will be. Okay, now let's move to vector subtraction. See students, there is nothing like vector subtraction. Okay, there is nothing like vector subtraction. We have only vector addition, we have only addition algebra. If I want to find A vector minus B vector, then I can write it as A plus minus B. I can write it as A plus minus B. What is minus B? It is negative of vector A. It is negative of vector B, sorry. It is negative of vector B. I want to find A minus B. It is just the addition of, minus B to A. It is just the addition of minus B to A. So A minus B is nothing but the addition of a negative vector. So if I have this as my A vector and this as my B vector, angle between A and B is theta. Angle between A and B is theta. What will be my minus B? Minus B will be having the same magnitude, just the opposite direction. This will be my minus B vector. Now I have to find is A plus minus B. So A vector plus minus B vector will be the diagonal of the parallelogram formed by these two vectors. So this diagonal will give me R equal to A minus B. This diagonal will be giving me R is equal to A minus B. This is how we can find vector subtraction. Now if I have R vector, is equal to A vector minus B vector, where theta is the angle between A and B. Okay, theta is the angle between A vector and B vector, then my magnitude of R will be equal to under the root of A square plus B square minus 2AB cos theta. It will be minus 2AB cos theta, and the angle beta, which this resultant is making with A, and the angle beta which this resultant is making with A, tan beta will be equal to B sin theta divided by A minus B cos of theta. This will be equal to b sine theta divided by a minus b cos of theta. So this is the magnitude of the resultant and this is the direction of our resultant. Now see, if we want to find if a and b are equal, same, if we have magnitude of a, if magnitude of a is equal to magnitude of b, if magnitude of my both the vectors is equal, that is magnitude of a vectors is equal to b vector, magnitude of a vector is equal to b vector, then my resultant will reduce to a shorter form 2a sine of theta by 2, 2a sine of theta by 2. So this is my formula if a and b are equal. This is valid only if a and b are equal. These are valid everywhere. Okay. So this is all about vector subtraction. Now see how we can resolve our vectors. How we can resolve our vectors. Resolution of vectors. If this is my x-axis and this is my y-axis. This is my x-axis and this is my y-axis, and I have a vector A. I have a vector A in the xy plane. It is making an angle theta. It is making an angle theta. Then I can resolve this vector into two components. I can resolve this vector into two components, ax and ay. Okay, ax and ay. So what I have is a vector is resolved into two components, ax plus ay. And see, by parallelogram law, a is the resultant of ax and ay. Now the magnitude of ax will be equal to a cos theta and magnitude of ay is equal to a sin theta. Okay, if we are given ax, if we are given vector a and we have to find ax and ay, the length of this vector will be a and the length of this vector will be ax and the length of this vector will be ay. Then ax will be equal to a cos theta, ay will be equal to a sin theta. From this triangle we can calculate that, and if opposite condition is given, we are given ax and ay, we have to calculate a. So a will be equal to under the root of ax square plus ay square. Similarly, tan of theta will be equal to ay by ax. Okay, tan of theta will be equal to ay by ax. If this is my vector a and I want to find a component along the axis with which it is making an angle theta, then the component along this axis will be a cos theta and the component along the perpendicular axis will be a sin theta. Okay, so this is vector resolution. Now see vectors in Cartesian coordinate system. Okay, if vectors in Cartesian coordinate system, this is my Cartesian coordinate system x, y and z. This is my Cartesian coordinate system x, y and z. We have a vector a like this. Okay, we have a vector a like this in the Cartesian coordinate system. Then vector a in Cartesian coordinate system is written as ax I cap plus ay j cap plus az k cap. Now what this ax, ay, az are and what this I, j, k are. Okay, I cap, j cap and k cap, these are unit vectors in the direction x, y and z respectively. Okay, we have defined three unit vectors, I cap, j cap and k cap. I cap is the unit vector in x direction, j cap is the unit vector in y direction, k cap is my unit vector in the z direction. We have defined three unit vectors to show the three mutually perpendicular directions. Okay, we have defined three unit vectors to show the x, y and z direction. These vectors are having magnitude 1 and they are mutually perpendicular to each other. Now see students, these vectors are having magnitude 1 and they are perpendicular to each other. These are called orthogonal vectors. They are also called orthogonal vectors. Now what is Ax, Ay, Az? We just now saw that if I have vector in 2D, I can resolve it into two components along the axis x and y. Similarly, my Ax will be component. Ax will be component of a vector along x-axis. It will be component of a vector along x-axis. Ay will be component of a vector along y-axis, and Az will be component of a vector along z-axis. This will be component of a vector along z-axis. These are my components of this vector along the x, y and z direction respectively. This is how we represent a vector in the Cartesian coordinate system. Ax is the magnitude in x and I cap is its direction. Ay, so we have resolved the vector into three directions and their combination is equal to a vector. Okay, this is how we represent it in Cartesian coordinate system. Now what will be my magnitude of the vector? What will be my magnitude of a vector? How can I calculate magnitude of a? Magnitude of a will be equal to under the root of ax square plus ay square plus az. Okay, this is how we calculate magnitude of a in Cartesian. This is how we calculate the magnitude of a in Cartesian system. Next is how can we find the unit vector? That is, how can we find the unit vector in direction of a, or how to tell the direction of a. Okay, if I want to tell the direction of a, then it can be told by the unit vector in the direction of a. Any unit vector pointing in the direction of a will give me direction of a. So we want to find a cap. So a cap is equal to a vector by its magnitude. What is my a vector? It is ax I cap, ay j cap plus az k cap divided by under the root of ax square plus a y square plus a z square. This is how I can represent my a vector. This is how I can represent my a cap. A cap, a unit vector in the direction of a. A unit vector in the direction of a. Now how to find direction cosines? How to find direction cosines of a? Direction cosines. If alpha is the angle made by a vector, with x-axis, okay, alpha is the angle made by a vector with x-axis, beta is the angle made by a vector with y-axis, and similarly gamma is my angle made by a vector with z-axis or z-axis. So this cos of alpha, this cos alpha is equal to ax by a, cos beta is equal to ay by a, and cos gamma will be equal to az by a. Cos alpha will be equal to ax by a, cos beta will be equal to ay by a, and cos gamma will be equal to az by a. These are called the direction cosines. These are called the direction cosines, and the value of cos square alpha plus cos square beta plus cos square gamma is equal to 1. And the value of cos square alpha plus cos square beta plus cos square gamma is equal to 1. So these are my direction cosines of, okay, these are my direction cosines of A. Then how to add vectors, vector addition. How to add vectors in Cartesian coordinate. Okay. How to add vectors in Cartesian coordinate system. If this is my vector A equal to ax I cap plus ay j cap plus az k cap. Okay. If I have two vectors ax I cap plus ay j cap plus az k cap and bx I cap plus by j cap plus bz k cap. This is my B vector. Then what will be my value of A vector plus B? Value of A vector plus B vector will be, replace it. So x component will get added to x component, I plus I, j plus j, k plus k. Okay. It will become ax plus bx I cap plus ay plus by j cap plus az plus bz k cap. So this will be my A plus B, and if I want to find A minus B, then it will be equal to ax minus bx I cap plus ay minus by j cap plus az minus bz k cap. So this will be my A minus B. Okay. This is my A plus B and this is my A minus B. Respective components will get added up and respective components will get subtracted. Okay. So next is for equal vectors. Equal vectors. So if we are given two vectors A and A is equal to ax I cap plus ay j cap plus az k cap, and we have another vector B equal to bx I cap plus by j cap plus bz k cap. Now we are given that A vector is equal to B vector. Okay. We are given A vector is equal to B vector. They are equal. Two vectors are equal only and only if their respective components are equal. See, these vectors are equal. A will be equal to B only and only if ax is equal to bx, ay will be equal to by, and az is equal to bz. Ax is equal to bx, ay is equal to by, and az is equal to bz. Okay. So the two vectors will be equal only and only if these conditions are being satisfied. For equal vectors, what we have is their respective components should be equal, then only they can be equal, because equal vectors are equal in magnitude as well as in direction. Now if we are given that they are parallel vectors, okay, that is A vector will be parallel to B vector only and only if it is a scalar multiple of that vector. So ax by bx is equal to ay by by is equal to az by bz is equal to some constant lambda. Okay, this is the condition for the vectors to be parallel. The condition for them to be equal is this, and the condition for them to be parallel is this. Clear? This is a condition for the vectors to be parallel. Now see, Next thing what we have is vector multiplication. Okay, vector multiplication. Now what is vector multiplication? When we multiply two vectors, force and displacement, we get a scalar work. However, when we multiply two vectors, angular momentum, when we multiply two vectors, position vector and linear momentum, I get a vector that is angular momentum. So vector multiplication is of two types. Okay, vector multiplication is of two types: scalar product. Vector product is of two types: scalar product, and the other is vector product, and the other is vector product. Now see, scalar product, the name only suggests that result is a scalar number. Okay, result is a scalar number. If I multiply two vectors and get the result as a scalar, this is called scalar product. And if we multiply two vectors and get the result is a vector, and the result is a vector, then my vector product, then the vector multiplication is called vector product. Clear? So result is a scalar in scalar product, result is a vector in vector product. Now see, let's see scalar product first. Let's see scalar product of vectors. Now scalar product, how we define scalar product of two vectors? It is defined as A dot B. It is written as A dot B. Okay, scalar product of two vectors A and B, it is written as A dot B. Now because it is having dot, also called dot product, also called dot product. So A dot B is equal to magnitude of A multiplied by magnitude of B multiplied by cos of the angle between them. Okay, this is my A vector and this is my B vector. The angle between them is theta. Then A dot B is equal to AB cos theta. Then A dot B is equal to AB cos theta. This is called my scalar product. This is called scalar product. This number, result is a scalar. Result is a scalar. After multiplying two vectors, we are getting a scalar number. This is scalar product. A dot B is equal to AB cos theta. Now let's study the properties of scalar product. What are my properties of scalar product? First is scalar product is commutative. A dot B is equal to B dot A. A dot B is equal to B dot A. Scalar product is commutative. Next property, scalar product is distributive. A dot B plus C vector, this will be equal to A dot B plus A dot, okay, this will be equal to A dot B plus A dot C. Now dot product for two parallel vectors. Dot product of two parallel vectors. If we have two parallel vectors, then theta between them will be 0 degree. So cos theta will become 1. A dot B will simply be equal to A into B. A dot B will simply be equal to A dot B. Next is for anti-parallel vectors, dot product of two anti-parallel vectors. Dot product of two anti-parallel vectors, theta will be 180 degree. So cos theta will be -1. Hence A dot B will be equal to minus AB. A dot B will be equal to minus AB. Okay. So for two parallel vectors, dot b will be equal to ab, and for two anti-parallel vectors a dot b will be equal to minus ab. For perpendicular vectors, for perpendicular vectors, the angle between them theta is 90 degree. So cos of theta will become 0. Hence a dot b will become, hence a dot b will become, a dot b will become 0, and this is very important. This is very important. Next is, if we want to find a dot a, angle between a and a is 0. So cos theta will become 1. So a dot a will be simply equal to a square. Okay, a dot a will simply be equal to a square. If I want to find I dot I, or I want to find j dot j, or I want to find k dot k, so all these are having the magnitude 1. So it will be equal to 1 square, that is 1. Okay, this will be equal to 1 square, that is 1. If I want to find I dot j, or j dot k, or k dot I, all of them are having angle of 90 degree between them. They are perpendicular, so their dot will become, okay, so their dot will become 0. Next is, if we are given vectors in the Cartesian form, okay, a vector is given as ax I cap plus ay j cap plus az k cap, and b vector is given as bx I cap plus by j cap plus bz k cap, then I want to find a dot b. Okay, I want to find a dot b. So a dot b will be the multiplication of respective components. I dot I will become 1, I dot j 0, I dot k 0. Similarly, only the components of same direction are surviving, rest will become 0. So a dot b is equal to ax bx plus ay by plus az bz. Very important. Okay, very important. This is what is my a dot b in Cartesian form. Next, if we are given two vectors, okay, in Cartesian form, and we want to find the angle between them, okay, angle between a vector and b vector, angle between a vector and b vector will be cos theta. We can write cos theta is equal to a dot b divided by magnitude of a into magnitude of. This is how we can find the cos of angle between two vectors. A dot b is ab cos theta, so cos theta will be a dot b by a magnitude into b magnitude. Now we know how to calculate a dot b, we know how to calculate a magnitude, how to calculate b magnitude. Put in this formula and we can get the angle between two vectors. This is a very important result. Okay, this is a very important result. So these are all the properties of dot product. Now let's study physical interpretation of dot product, or where it is being used. So projection is basically shadow of one vector over the other. If we want to find, this is my b vector and this is my a vector, okay, or let's take opposite. This is my a vector and this is my b vector. I want to find projection of a along b. Okay, I want to find projection of a on b. Then it is basically the shadow of a. The projection of a on b, it is the shadow of a in the b direction, or component of a in b. Just draw the shadow of a over b. This will give me projection of a. This is projection of a on b. Projection of a on b. Clear? So projection of a vector A on vector B is the component of A in the direction of B. It is the component of A in the direction of B or along B. Now how to calculate? How to calculate it? Projection of A vector on B vector is simply component of A in direction of B. It is component of A in direction of B, that is A dot B cap. It is A dot B cap, component of A in the direction of B. A dot B cap will give me the projection of A on B. Now let's move to vector product. Okay, vector product. So the vector product of a cross product of, okay. Why cross product? Because vector product is written as A cross B. Okay, it is written as, represented as A cross B, hence it is also called cross product. Hence it is also called cross product. So the vector product is equal to A cross B. This is equal to magnitude of A into magnitude of B into sine of angle between them, into sine of angle between them, and the direction n cap, and the direction n cap. Now see, A cross B is equal to AB sine theta, and the direction is n cap. So what we are getting is, result is a vector. Okay, result is a vector. After multiplication of two vectors, we are getting a vector. We are getting a vector. So the vector or cross product of two vectors is the vector whose magnitude is equal to product of magnitudes of two vectors and sine of angle between them, and sine of angle between them. And direction. How to find the direction? Direction is perpendicular to the plane of two vectors and is given by the right hand thumb rule. This n cap is a direction. Let's see how we can find the direction of n cap. This is my A vector. This is my B vector. Theta is the angle between them. Okay, theta is the angle between them. Now what A cross B will be? See, curl your fingers of the right hand. Curl the fingers of the right hand. Curl the fingers of the right hand in the sense of rotation from A to B. If we are finding A cross B, then curl the fingers from A to B. The thumb will give you the direction of A cross B. Okay, curl fingers from A to B. Curl fingers of right hand. Curl fingers of right hand from A to B. From A vector to B vector. Then thumb will provide A cross B. Okay, then thumb will provide A cross. Okay, thumb will give us the direction of A cross B. Curl the fingers of your right hand in the sense of rotation from A to B, then thumb will give us the direction of A cross B. Now see, here A cross B is out of the plane of paper. So A cross B is perpendicular to A cross B is perpendicular to A, as well as A cross B, as well as A cross B is perpendicular to B. Okay, A cross B is perpendicular to A cross B is perpendicular to B. This n cap is perpendicular to both the vectors. Okay, the n cap here will be perpendicular to A as well as perpendicular to B. That is why we say that it is perpendicular to the plane having A and B. It is perpendicular to the plane having A and B. If this is my A B2 vectors, then the plane having them will be the plane of board. So A cross B will point outwards and B cross A will point inwards. They are perpendicular to the plane. Okay. Now see A, B, theta. Now find A cross B. A cross B is, curl the fingers from A to B out of the plane. Okay, out of the plane. Now same, find B cross A. Find B cross A. B cross A will be into the plane. Curl the fingers from B to A. Curl the fingers of the right hand from B to A. B to A, the thumb is pointing inward. So this will point in the direction into the plane. It is into the plane. So A cross B and B cross A are opposite to each other. Okay. A cross B and B cross A and B cross A are opposite to each other. They are opposite to each other. They point in the opposite direction. Okay. Now let's study properties of vector product. So property, vector product, first property is vector product is anti-commutative. A cross B is equal to minus of B cross A. A cross B is equal to minus of B cross A. Vector product is anti-commutative. Then next property, vector product is associative over addition. So A cross B plus C, this will become A cross B plus A cross, this will become A cross B plus A cross C. Next property, so for parallel or anti-parallel, let's say for collinear vectors, okay, parallel or anti-parallel, okay. So collinear vectors, theta will be 0 or 180 degree. So sin theta will become 0. So A cross B will become 0. It will be a null vector. Okay, it will be a null vector. A cross B will have the magnitude 0, so it will be a null vector. Fourth, A cross A. If we want to find A cross A, it will also be a null vector. It will also be a null vector because angle between A and A will be 0. Next, perpendicular vectors. So for perpendicular vectors, theta will be 90 degree, sin theta will become 1. So A cross B will have the magnitude AB, sin theta will become AB. Okay. So this is the maximum value of the cross product. Next is, if we have I cross I or J cross J or K cross, this will become a null vector. This will become a null vector. Next is, if we want to find I cross J, okay, if we want to find I cross J, now draw, this is I cap, this is J cap and this is K cap. Now see, I cross J is giving me K, I cross J is giving me K. Now find J cross K, find J cross K. So J cross K is coming along I cap. Now find K cross I, find K cross I. So K cross I, K is outwards, K cross I will give me J cap. Okay, so there is a rule by which we can remember, write I J K like this. Okay, write I J K like this. This direction anti-clockwise will be taken as the positive direction. Anti-clockwise rotation will be taken as positive. Anti-clockwise rotation we will take as positive. Okay, now see, I cross j. Okay, I cross j, we have I, we have j, and then we have k. Okay, so I cross j will give me the third one k. I cross j will give me the third one k. J cross k will give me third one I. K cross I will give me third one j. But if the sense of rotation is anti-clockwise, clockwise rotation will be taken as negative. Okay, clockwise will be taken as negative. If we want to find j cross I, if we want to find j cross I, see, find j cross I. J cross I moving in opposite, so it will be minus k. J cross I will be minus k. Similarly, I cross k. I cross k will be minus j. This is the third. Okay, this is how we can find the cross product of I, j, k orthogonal vectors. Next is, if we are given vectors in the Cartesian form. Okay, a vector is given as ax I cap plus ay j cap plus az k cap, and b vector is given as bx I cap plus by j cap plus bz k cap. Now I want to find a cross b. Okay, I want to find a cross b. Then a cross b can be found by the determinant method. It can be found by the determinant method. Write I, j, k in the first row. Then because a is written first, write the components a first. So under I write x component, under j write y component, and under k write z component. Then write the component of b, bx, by, and bz. Bx, by, and bz. Then write plus minus plus over I, j, k. Then write plus minus plus over I, j, k. Now open this determinant. Because we have plus, so write plus I cap. Remove the row and column of I. How to calculate this determinant? Write plus minus 1. We are using I cap, so plus I cap. Remove the row and column of 1. Multiply in this direction first. Okay, multiply in this downward direction first. Multiply in this downward direction. Then put a minus sign. Then multiply these two. Put a minus sign. Then multiply in this direction. Okay, then multiply in this direction. So cross. Remove the row and column of I cap, multiply downwards first. So ay into bz, ay into bz, put a minus sign, then by into az, by into az. Then next is j, so write minus j cap, write minus j cap, remove the row and column of j cap. Multiply in downward direction first, ax bz minus bx az. Okay, minus bx az. So remove it, ax bz minus bx az, minus bx az. Then we have k cap positive, so write plus k cap. Remove the row and column of k. Multiply downwards first, ax by, then put a minus sign, then bx ay, then bx ay. So this is how we can calculate the determinant or calculate a cross b if we are given a and b in the Cartesian coordinate system. Okay, next is 9th, sine of angle. Okay, angle between a and b. So if we want to find angle between a vector and b vector, now see, we have magnitude of a cross b is equal to ab sine theta. So from here we can calculate that sine of theta will be equal to magnitude of A cross B divided by magnitude of A into magnitude of B. This is how we can find sine of theta. Okay, this is how we can find sine of theta. Next is the physical. These are all the properties of vector product or cross product. Now let's see the physical interpretation or geometrical importance. Physical interpretation or geometrical importance, we can say that. Geometrical significance. Now in geometrical significance, if A vector and B vector are represent two sides of a triangle. Okay, if A vector and B vector represent two sides of a triangle, then area of triangle is equal to half into magnitude of A cross. Okay, area of triangle is equal to half into magnitude of A cross B. Half into magnitude of A cross B. If A and B represent two sides of a triangle, then area of triangle is half times the magnitude of A cross B. And if we have, if A vector and B vector represent two adjacent sides of a parallelogram, two adjacent sides of a parallelogram, okay, then what will be my area of parallelogram? Then area of parallelogram is equal to magnitude of A cross B. Okay, area of parallelogram is equal to magnitude of A cross B. So this is the physical importance or physical geometrical interpretation, or anything you can call it, of cross product. If A and B are the two sides of a triangle, then area of triangle is half the magnitude of A cross B. And if A vector and B vector represent two sides of a parallelogram, which sides? Adjacent sides of a parallelogram, then area of parallelogram is equal to magnitude of A cross B. So this is all about vectors. I hope you enjoyed this session. This is a quick recap of the chapter vectors. We have covered all the topics that we have studied in this recap. Use this recap whenever you want to recapitulate the formula or want to make a formula sheet. Okay, keep studying. All the very best, students. Work hard and keep rocking. Thank you. Take care. Goodbye.